our topic is moving iron type instrument. Moving iron type instrument. So what we see in moving iron type, the most common ammeter, voltmeter of laboratories which are used moving iron type instrument. And it's we have first discussed about the general torque equation. So general torque equation for moving coil instrument. Suppose there is the TD is the deflating torque. TD is the deflating torque and theta is the deflation. Small deflation is the d theta. So if we see then and the mechanical work done is equal to TD into d theta. So alongside there will be the small energy stored in magnetic field, so field owing to the change of inductance. Suppose the initial current is I and the instrumental inductance is L and theta is the deflection, then current increase to di, I2 increase to di and L is increased to dl and in theta is increased to d theta. Then what happened if the instrument di is the current, then the applied voltage E is given by d by dt of L of I. So what happened, d of dt Li, if we differentiate it, it go idl by dt plus L di by dt. Then if we calculate this, what we have given that L di dt is the electrical energy supply, electrical energy supplied. EIDT. So EIDT we get E that, then EIDT is equal to I square dl plus ILDI. Then suppose the stored energy change from half I square L to half 1 I plus di tar whole square L plus dl. So total change this minus that, so half I plus di square L plus dl minus half I square L. So if what we get, neglecting the higher term I dl plus half I square dl, neglecting the higher terms. So from the principle of conservation energy we get IL dl plus I square L dl plus I dl theta. Electrical energy is equal to the electrical energy supplied is equal to increase in stored energy plus mechanical work done, means I square dl plus ILDI equal to ILDI is nothing but half I square dl plus TD into d theta. So we get TD into d theta is equal to half I square dl. So TD deflating torque is equal to half I square dl by d theta. But T is the Newton per meter, I is the ampere and L is the Henry and theta is in radian. So if we take the deflection theta, so theta we get half I square by k dl by d theta. Classification of moving iron can be divided into two. One is attraction type and second one is the repulsion type. So what we see attraction type, there the attraction type, there is a moving iron, here there is air chamber and air chamber is connected, there is moving iron and it is connected to a pointer, there coil winding, there is a balancing weight and here there is a control weight. So if we see the working principle, here the coil is flat type and has a narrow slot like the opening. The moving iron of flat disc or sector electrically minded. When the current flows through it, then its flow through the coil and magnetic field produced, and moving iron moves from the weaker field to the stronger field inside it, and it's work with the moving iron attached to it. Damping is provided, controlling torque is provided by spring, but gravity control can be used for panel type the instrument which is vertically mounted. Second one is the repulsion type. Here we see that there is a two type, radial vane type, and second one is the coaxial vane type. In radial vane type there will be a coil. The coil is mounted and there is a movable vane. In coil there is a movable vane, and there is the fixed vane. There is a pointer or deflector. And for coax, this is the radial type. And for coaxial type, there will be the movable vane. Here is a spring, movable vane, and there will be a coaxial coil. There is a spindle, and there is fixed vane. So first we see the radial type. There is a radial strip of iron, and it is the strip are placed in the coil in the figure. The fixed vane is attached to the coil. Attached to the coil, and it is the movable one is the spindle of the instrument. And for coaxial type instrument, there will be the fixed moving vanes is used in the, and the controlling torque is provided by the spring, and gravity control is the used to vertically mounted the instrument. The operation of operating the damping torque is provided by air friction is the Ataxet type instrument. So now what are the we use the moving iron type instrument. What are the advantage and disadvantage of moving coil type instrument? First of advantage, we use this is in both AC and DC, and it is used universal use. So both we see the PMC is only used for AC, it is for AC and DC both, and less friction, error, cheapness, robustness, accuracy, scale, error, waveform errors. These are the advantage, and there are the calibration which are less friction errors. These are the advantage.